Now we are going to solve some problem which is based on hyperbola. So the first equation is, that is the first problem is, obtain the equation of the hyperbola whose focus is 0, 1 and the equation of the directrix is x plus 3 is equal to 0 and eccentricity is under root 2. Now the solution is, as we have Sp is equal to E times Pm, as we suppose P is a point on the hyperbola with coordinate xy. That gives Sp square is equal to E square Pm square, that is the perpendicular distance of P from the directrix. X is equal to minus 3 here, or x plus 3, and here s is 0, 1. So by using distance formula we get x square plus y minus 1 square, under root is cancelled out by square, and here e square perpendicular distance is modulus x plus 3 whole square over under root 1, and here e is under root 2. So we get x square plus y minus 1 whole square, under root 2 whole square is 2, and we get x plus 3 whole square. So open the bracket using a minus b whole square formula in place of y minus 1 whole square, and a plus b whole square in case of x plus 3 whole square, and we get x square plus y square minus 2y plus 1 on left hand side, and on right hand side 2 times x square plus 9 plus 6x. So on solving these, we will get x square minus y square plus 2y plus 12x plus 17 is equal to 0, which is the required equation of the hyperbola. Now the next problem is, point P is a variable point such that difference of its distance from fixed points S and S dash, which are 12 units apart, is constant. 8. Find the point set of P. What does it describe? That is called point set of P. Now the solution is, according to given condition, we have difference between distance from fixed point, that is SP minus S dash P or S dash P minus SP. So we take in the modulus value, whatever it may be, is equal to constant 8. So we have this given condition. But from the property of hyperbola, we have modulus value of Sp minus S dash P is equal to 2a. That is constant. We can say that is 2a is equal to a. That gives a is equal to 4. And another condition is S S dash both are apart 12 units. So if we see distance between, that is on the transverse axis, we have this is 2c, so we get 12, that is c is equal to 6, and this c means AE because we are saying this and this point is 12 meter apart and we are saying this distance and this is 2c, total 2c, that is there is a point in the middle. This distance is c and this distance is also c, and this c means AE, 0. Therefore, 6 is equal to AE and we have the value of A and we get E from here, that is 6 over A, that is 6 over 4, that is 3 over 2. As we have A and E, we can find out B. B square is equal to A square into E square minus 1. So we get A square is 16, E square is 9 over 4 minus 1. That gives 4 into 9 minus 5. So we get 4 into, that is 9 minus 4 by taking LCM. So we get 4 into 5, that is equal to 20. So we get the value of B square as 20. Therefore, equation of hyperbola is x square over 16 minus y square over 20 is equal to 1, which is the standard equation of hyperbola. Now the next problem is, that is problem number 3. For the following hyperbola, find the coordinates of Foci, the equations of directrix, eccentricity, length of lattice rectum, length of transverse, and conjugate axis. And the equation is x square minus 16y square is equal to 16. Now the solution is, as we have x square minus 16y square is equal to 16. To make in standard form, divide by 16 and we get x square over 16 minus y square over 1 is equal to 1. So here a square is equal to 16 implies a is equal to 4 and b square is equal to 1 implies b is equal to 1. Also, we know that b square is equal to a square into e square minus 1. That gives value of b. Substitute in this. We get 1 is equal to 16 into e square minus 1. That gives 1 over 16 plus 1 is equal to e square. So that gives e square is equal to, by taking LCM, 17 over 16. That implies e is equal to under root 17 over 4. Therefore, Fokies are plus minus AE, 0. That is, A is 4, E is under root 17 over 4, 0. That is, plus minus under root 17, 0 are the coordinates of Fokies. Now we have to find directrix. So directrices are x is equal to plus minus a over e, that is plus minus 4 over under root 17 over 4. That gives plus minus 16 over under root 17. Now as we know the value of a and b, and with the help of these we can find the length of latus recta, that is 2b square over a, that is 2 into 1 square over 4, that is 1 over 2. Now we have to find length of transverse axis, which is equal to 2a, that is 2 into 4, which is equal to 8, and length of conjugate axis, which is equal to 2b, that is 2 into 1, that is 2. So this was all about how can you find out so many quantities from the given equation of hyperbola. Problem number 4 is, find the equation of the hyperbola from the condition, one condition is Fokies are plus minus 7, 0 and vertices are plus minus 5, 0. So from these two conditions we have to find the equation of the hyperbola, as Fokies are plus minus 7 is equal to 0, that is AE is equal to 7 and minus AE is equal to minus 7. So we get AE is equal to 7, and vertices are plus minus 5 comma 0, that is a comma 0 minus a comma 0, that is a is equal to 5. Therefore, from a is equal to 7, we get 5e is equal to 7. That gives e is equal to 7 by 5. Now we have a, e, then we get the value of b. So b square is equal to e square minus 1 into a square. So e square means 49 over 25 minus 1 into a square, that is 25. So we get 49 minus 25 over 25 into 25. That is b square is equal to 49 minus 25 is equal to 24. Therefore, equation of hyperbola is x square over a square, that is 25, minus y square over b square, that is 24, is equal to 1, which is a required equation of hyperbola. Now the next problem is, that is problem 5. Find the equation of hyperbola with condition first, distance between foci is 16, that is foci on x-axis, and eccentricity is under root 2. Now the solution is, as distance between foci is 2AE, and we have this 2AE is equal to 16. That gives AE is equal to 8. And we have E is equal to root 2. Therefore, A root 2 is equal to 8. That implies A is equal to 8 over under root 2. So, add the irrational function is in the denominator, so rationalize it by root 2. So, we get 8 under root 2 over 2. That gives 4 under root 2. A is 4 under root 2, and we have to find B, and as we know that B square is equal to A square into E square minus 1. That gives A square means 4 square is 16, under root 2 square means 2, and E square is under root 2 square is 2 minus 1, gives, that is 32 into 1 is equal to 32. And now we have b square is equal to 32 and b is equal to under root 32, that is 2 into 2 into 2 into 2 into 2, that is 32, 2 raised to power 5. So we get 2 into 2 out, under root 2 is there. That is 4 under root 2. That is A is equal to B, which is equal to 4 under root 2. That means hyperbola is rectangular hyperbola. So, equation of rectangular hyperbola is x square minus y square is equal to a square, that is 4 under root 2 whole square. That is, we get x square minus y square is equal to 32, which is the required equation of rectangular hyperbola.